Welcome back to CS201 walkthroughs. My name is Lukash, and today we're going to be talking about Turing machines. So as you might know, these were a sort of thought experiment by Alan Turing, a famous early computer scientist, but today we're going to be focusing on this example of a Turing machine, which I have written to take in a tape of ones and zeros, with the head on the left of the tape, and to output a string of zeros and ones in alternating order, so 0, 1, 0, 1, 0, 1. Okay, so there are two parts to a Turing machine, the tape and the instructions. The tape is comprised of a theoretically infinite length of zeros and ones. On each side, you can have, at least in our representation that we're going to be using, we're going to have blanks kind of filling in the ends, which we'll represent with the letter B, or the symbol B in Racket. But for now, I'm just leaving it as ... assuming that this goes on infinitely. You have a head pointing to a particular position on the tape, and this head can move back and forth, or I guess the tape can move, but the head can be pointing to different elements at different times, as we'll see. Then we have the instructions. The instructions contain 5 columns, at least in our representation. So depending on what the current state of the machine is and what symbol you're looking at, you're going to have a new state and a new symbol, and then a direction that the head moves. So I think the best way to kind of think about this is through example. So here we have the head pointing to a 1, and we're going to start in Q1. So right now we're in state Q1. We look and we say, okay, we go to this table, our current state is Q1, our current symbol is a 1, that's what we're looking at. That means that the new state is going to be, okay, still Q1, we're going to change that symbol to a 0 and move to the right. So let's see what that looks like. Okay, so the head is now pointing at this second element, or the second digit in the list. Still in Q1, as we said, the new state was Q1, but this 1 here has been changed to a 0, because you can see current symbol 1, new symbol 0. So now we have different contents on the tape. Head is pointing to the second instead of the first element because we moved to the right. Okay, so all we have to do is keep following these instructions. That's pretty easy, right? So Q1 points to a 0, the head in state Q1 points to a current symbol 0, so we're going to leave it as a 0 and stay in state Q1, right? So we're going to keep doing this. It appears that we're not going to change out of Q1 for a little bit, because if we see a 1 or a 0, we're staying in Q1 and going to the right. We're only going to change when we hit a blank. So here we keep going, we move to the right again, and now we're on the third element. We leave that 0 as a 0. So basically what this does is it changes all 1s to 0s, leaves all 0s as 0s, and just moves to the right until it hits the very right of the tape. Once it hits a blank, you can see we're going to have a new state. The state is going to change from Q1 to Q2. We're going to leave that blank alone and then move to the left. So here we got to the end of the tape, we're in Q1, we see a blank, these ... kind of represent our blank. We're going to move to the left and move to Q2. So here we are in Q2, pointing to the last 0, and we're going to, again, look in the instructions and see what we're supposed to do. So Q2, the current symbol is a 0, it says we're going to move to Q3, and the new symbol is still going to be a 0, move to the left. So this may not seem like it's doing much. Remember, I said that this is going to leave us with a string of alternating 0s and 1s. The strategy I took to do this is to alternate between state Q2 and Q3. So here you can see that state Q3 will change a 0 to a 1, and state Q2 will leave a 0 as a 0. There are definitely more efficient ways to write this machine. This is just for demonstration purposes. So after we see the 0, we're going to leave it alone, because Q2, seeing a 0, leaves it as a 0, but we're going to change to state Q3. Okay, so here we've changed to state Q3. We've moved 1 to the left, as we were supposed to. We left it as a 0, but now when we see this 0, we're in state Q3, and when we look up state Q3 encounters a 0, changes it to a 1 and moves back to Q2, moves to the left. So here we have what that looks like. We changed this 0 into a 1, move to Q2, to state Q2, and move 1 digit to the left. So you can see how these are going to go back and forth, kind of marching along this tape, chugga, like a train, I guess, changing every other 0 into a 1, because we're going to alternate back and forth between state Q2 and Q3 until either of them encounters a blank. So the way that you halt in the way that you halt in a Turing machine is you go to a state that you try to look up an instruction. You say, okay, we've gone all the way to the end of this tape. Q3 is now pointing at a blank. When Q3 points at a blank, it says move to Q4, leave the blank alone and move to the right. Now we're in Q4. Q4, I'm going to say, has no instructions. The halt state has no instructions, which means that the Turing machine is done. When you try to look up instructions and you don't find any, that's your indication that your Turing machine is halted. So this was a pretty simple example of a Turing machine. Just has a couple states, or a few states, runs to the right, changing everything to a 0. Once it gets there, it senses a blank. It goes back, changing half of the 0s to 1s, leaving the rest alone, alternating between states Q2 and Q3. And then it ends in state Q4 after it hits the blank on the left. So I hope this has given you some sort of idea of what a Turing machine is. We're going to be writing them in our Racket P set. The next video is going to be about how we represent all of this stuff in Racket. So I hope to see you there. As always, if you have questions, come into office hours, post on the Piazza, or email the CS201 help email, and thanks for watching.